This will be for the con exercise, modeling with sinusoidal functions. Okay, before beginning this exercise, you want to be familiar with the basic sine and cosine functions. Okay, so right here, this is the shape of y equals sine of x. And down here, this is y equals negative sine of x. This one here is y equals cosine of x. And this one here is y equals negative cosine of x. So we're going to start each equation by choosing from one of these four graphs. So after the write-up, we're going to do a sketch of this graph, and then we're going to try to write the equation. All right, it says Kaliska is jumping rope. The vertical height of the center of the rope off the ground, r of t in centimeters as a function of time in seconds, can be modeled by this sinusoidal equation. All right, so this is the equation we're going to use. At t equals 0, when she starts jumping, the rope is 0 centimeters off the ground, which is the minimum. And then after pi over 12 seconds, it reaches a height of 60, which is half of its max. Find r of t. All right, we're looking to write the equation. So basically, you want to sketch the graph and then try to write the equation based on that. All right. So for all of these, I'm basically going to start at the y-axis and then head in this direction. All right. The x-axis is actually t. It's in terms of t. See the equation r of t. All right. Anyhow, let's read this again. T equals 0. The rope is 0 centimeters, which is the minimum. Okay, so this is the lowest point right here. And then after pi over 12, it reaches a height of 60, which is half of the max. All right. So it goes up, goes to the max, and comes back down. Okay. And they said 60 is half of the max. So about right here is 60. All right, if it starts at 0 and half of the max is 60, that means the maximum is going to be 60 times 2, which is 120. All right, and they said it goes from the minimum to half of the max in pi over 12 seconds. So this point right here is going to be pi over 12. All right, and now we can write our equation. All right, based on the four graphs I showed you at the beginning, this is clearly a negative cosine. All right, so it's going to be a negative cosine. And we need to find the amplitude here. Remember, the amplitude is halfway from minimum to maximum. So if you started at 0 and went halfway up, you would be at 60. So the amplitude is just 60. And now we want the value of b. All right, if you check out the form of their equation, b is a number that's multiplied by t. All right, normally it's multiplied by x, but now we're using t. So first, what is our period? Let me make a little room up top here. All right, the period, we went from minimum to the midline, because we said half the maximum. We went from minimum to the midline and pi over 12. This distance right here is only 1/4 of the period. Remember, the period has to go all the way from minimum to maximum back to minimum. So this section is only 1/4. We have to multiply pi over 12 times 4. Okay, 4 times pi over 12. 12 divided by 4 is 3, so that's going to be a pi over 3. And the formula for period equals 2 pi over b. Okay, cross multiply, b times pi equals 3 times 2 pi. 3 times 2 pi is 6 pi. So clearly B equals 6. Okay, they're both times pi. So B equals 6. All right, so in the equation, for the B, we're going to put 6. We're going to put cosine of 6t. All right, so that's cosine of 6t. And now the easy part is the midline. Okay, that is easy because we have the center of the graph. We said half of the maximum was 60. All right, if you go right down the middle of this graph, the midline, right down the middle, that's at 60. So we have a plus 60 on the end. All right, so in the box, negative 60 cosine, parentheses, 6t, click outside the parentheses, and plus 60. Okay, please make sure you use t and not x. All right, you have to use t and not x. All right, these are all basically the same. You're going to read the write-up, draw a sketch, and write the equation. Valeria is playing with her accordion. The length of the accordion A of t after she starts playing as a function of time can be modeled by this expression here. At t equals 0, when she starts, the accordion is 15 centimeters, which is the shortest. 1.5 seconds later, the accordion is at its average of 21. All right, so we're using a cosine function. Actually, I don't think we have to use a cosine function. We can probably use cosine or sine. But let's draw the sketch and we'll see. All right, so we're going to draw our sketch. And I'm pretty sure in every case, this axis is going to be t for time. All right, at t equals 0, 15, she's at 15, and that's the shortest, okay? That is the minimum. That's going to be at 15. So 15 is the minimum. And then 1.5 seconds later is at the average, which is 21. Okay, so it basically starts to head up. It's going to reach a max and then come back down. All right, so 15 is the minimum. 21 is the average, so that's basically going to be the midline right there. All right, so that's 21. If 15 is the minimum and 21 is the average, we jumped up 6 units. 21 minus 5 is 6. So add another 6. And the maximum is going to be at 27. All right. So from the 4 graphs we did at the beginning, this is clearly a negative cosine once again. All right, leave some space for the amplitude. This is going to be a negative cosine. All right, so let's see the amplitude. Remember, that is half the distance from minimum to maximum. So if we just went from here to here, we go from 27 to 21, so that's going to be 6 units. All right, and now for the period. It went from the shortest to the average in 1.5 seconds. So from here to here, this point right here is going to be 1.5. All right, so this distance right here is 1.5. That is only 1/4 of the period because we only went from the minimum to the average. That's only 1/4 of the period. So to find the period, we need to multiply that number by 4. All right, so the period is going to be 4 times 1.5, which equals 6. And we know the formula for the period is 2 pi over b. Okay, cross multiply, 6b equals 2 pi, and then divide both sides by 6. B is going to equal 2 pi over 6. And dividing both by 2, that's going to be 1 pi over 3, or just pi over 3. All right. So B is the number that's multiplied by T inside the parentheses for the cosine. All right, so that pi over 3 is B. So inside the parentheses, we're going to have pi over 3 times T. All right, don't forget, this is T, not X. All right, because it's in terms of time. Finally, the easy part, the midline. And I said it at the beginning, the average was 21. See this midline right here that cuts the graph in half horizontally. That's at positive 21. So that's it. All right, click in the box. We have -6 cosine parentheses. And that's going to be pi. I'll type pi/3. Pi over 3. Hit the right arrow key and type T. Okay. Hit the right arrow key again. Outside the parentheses, we have plus 21. All right, so that's it. Make sure you use T and not X. Okay, Dingain has been observing a certain stock for a few years. He sees it can be modeled as S of T in terms of time using this expression. On day T equals 0, the stock is average at 347 a share. 91.25 days later, its value is down to a minimum. All right, let's sketch this. So the graph is in terms of T. I believe that is the case for all of these. All right, at T equals 0, the average is 347. So right here, that's going to be 347. All right, 91.25 days later, it goes to the minimum. So it starts at the average and it goes to the minimum. Okay, then of course it's going to come back up. So the minimum value is $1.97. So right here, it's going to be $1.97 at the minimum. All right. Now, do we need to find the maximum? No, we don't need it. All right. So this is a negative sign. Based on the 4 graphs we did at the beginning, this is a negative sign. So I'm going to start with that. Leave space for the amplitude. Negative sign. And the amplitude is halfway from the minimum to the maximum. Okay, so we can start at the minimum here and go up to the average or halfway point. So 347 minus $1.97. 3.47 minus $1.97. That is going to be 150, if I'm not mistaken. Yes, that's going to be $1.50. So that is your amplitude, 150. You can put 15 or 150, either one. All right, let's find the period now. They said from the average to the minimum, it took 91.25 days. So this distance right here is only 1/4 of the period, all right? This is 91.25. All right, that's only 1/4 of it. We need to multiply it by 4. 91.25 times 4. Pretty sure it's going to be 365. Let me see. Yes, it's 365, and that's actually pretty common, okay, because that's the number of days in a year, so that is a full cycle. Formula for period is 2 pi over b. All right, cross multiply, 365b is 2 pi. And dividing both sides by 365, b is going to equal 2 pi over 365. Okay, I don't think they make you reduce that, so I would like to leave that as is, 2 pi over 365. So b is the number that's multiplied by t. inside parentheses, 2 pi over 365, and that's going to be times t. Now the midline is easy. That is the line right down the center of the graph. All right, and that's clearly at 347. So that just goes on the end. All right, so we have negative 1.5 sine, parentheses. I'm going to type 2 pi slash 365. Hit the right arrow key, times t. Hit the right arrow key, outside parentheses, plus 3.47. All right, make sure you use t and not x. All right, one more, but if you understand this by now, you're good to go. They're all basically the same. Toy boat is bobbing on the water. Its distance from the floor as a function of time can be modeled by this function. T equals 0 when the boat is exactly in the middle. It's 1 meter above the floor. The boat reaches its max of 1.2. All right. Quick sketch here. As usual, it's in terms of t, so the x-axis is t. Okay, at 0, the boat's in the middle of its oscillation, 1 meter above the floor. Okay, so right here is going to be 1. That's right in the middle. And then it heads to the max at 1.2. So it's going to go up to the max, like so. All right, so it says the maximum is 1.2. So up here, this is going to be 1.2. All right, so basically I went from average to max and then just kept drawing the function. So clearly this is a positive sine function. All right, and we need our amplitude. So they said the average is 1 and it heads up to a maximum of 1.2. So that distance, 1.2 minus 1, is just 0.2. All right, for the period, they said the middle to the max took pi over 4 seconds. So for this point right here, that's going to be at pi over 4. All right, so this distance is only a fourth of the whole period. All right. So if this is only a fourth of the period, this needs to be multiplied by 4. So the period is going to be 4 times pi over 4. And that's just pi. The formula for period is 2 pi over b. Okay, so clearly b is going to be 2. So that's the number that's multiplied by t. Normally it's multiplied by x, but we're using t. So in the parentheses, it's just going to be a 2t. And now the midline is the easiest. That horizontal line that goes right down the middle, that's at 1. Okay, and it says it right in the problem. The middle is 1. So on the end of this equation, you just have a plus 1. All right, so 0.2 sine, parentheses, 2t, outside parentheses, plus 1.